Hey there, and welcome to this video. So we will talk about JUnit 5, and we talked a bit about unit testing in the previous video. So this video is basically about how can we create a unit test for a class in Java here. So we have a calculator class, and we're inside IntelliJ IDEA. And it's just a normal console Java application. We can see we have a main file here with where we test also the calculator. But if we take the calculator class, it's really simple. We have the normal operations that we have in a calculator: add and subtract and multiply and divide, and we have input parameters, and then it will return the value. So if we run the program here, let's just right click and run here. We can see if we run the program, we get this output that basically the calculator works. We're adding and we are subtracting, we are multiplying, dividing. So the calculator works, but it is better, it is more optimal to use a unit test because we can automate our testing process and we can rerun the test again and again. We don't have to use our main method to run our tests. So how do we do this? Well, first we need to import our JUnit dependency, and the easiest way to do this is that we go to project structure, then we create a new library, we choose Maven, and then we search for org.junit.jupyter, and then we click search. And then we can see that Maven will find a lot of different versions for JUnit about migration support, the engine. We can see we have API, and we also have just JUnit Jupyter. So we will take this version here, 552, and I'm just going to download it to my lib folder and click transitive dependencies and hit OK on that. So it will add it to the project. All right, we can see the jar files over here. Click apply and OK. So now we have the dependencies needed for running unit test. So next up is that we should create a test directory because we should keep our test files separate from the source files because they are not needed when we need to deploy our app. So we should keep the tests away from the source files so we have a nice clean separation of concern here. And if we right click and create a new directory and just write test, then we can right click on that, and then we can mark directory as tests sources root. All right, then we can make use of IntelliJ, a feature that is in there, and we can put the cursor on the class name, and then we can hit Alt insert, and then we have test. This will bring up a wizard dialog from IntelliJ where we can see what testing library do we want to use, and we have various frameworks we can use, and we're just going to take JUnit 5 here, and then we specify the class name of the class that should host our tests. So that is calculator test. We can modify this if we want to do this, and we can also specify a superclass. We can also specify the destination package. And then eventually, if we need to have setup and teardown methods, then we can specify it here. And we use the setup and teardown to put all the code in there that is required for our test to work if we need to do some setup and teardown code. So as it says here, before and after, we can run some code that is necessary for the test to work. And then in the end here we have all the functions, all the methods that are in the calculator, and I'm just going to check all of them. And I'm just going to wait with the divide because of course you can also do this manually. And we can see if we just zoom a little bit out here that we can also write this manually. Of course, we don't have to use the wizard or the guide from IntelliJ, but it's an easy way to do it. So we can basically just make a new class called calculator test in the package, import the dependencies. We can see we have the API test. This will allow us to make unit test methods, and then we also have assertions. And this is not being used in at the moment because we're just making the methods, but we will use them just briefly here. Okay, so we have a calculator test, and if we can see if we right click on calculator test, we can say run calculator test or Control Shift F10 on a Windows machine, and then IntelliJ is going to run the test. Of course, we don't have any content in here in the test at the moment. So actually they will pass all of them, even though we didn't provide anything in here. Okay, so we have set up a basic class here, calculator test. We haven't made any actual assertions or tests in here, but let's try to do that. So we have add, and we have subtract, we have multiply. And if we go into the add first, then I would like to introduce a pattern that we can use to structure our unit test, and it's called the AAA pattern. And that is short for arrange. That deals with setting up our test objects, etc. Then we act, do the actual calc or method run, and then assert. Check if actual value is equal to expected. So this is one way of doing it, that we separate our unit test in an arrange part and act and assert. So how does this work in practice if we should test our calculator? Well, we can see that our add method will accept two input parameters, two integers, number 1 and number 2, and it's going to add them really simple. So our range could be something like this: calculator equals new calculator. So we're setting up our object to test. Then we do the actual calculation here, or we run the method. So we say calc add, and then we can take 20, 10. Okay, so we are running the function here, or the method here, and this will produce an output. It's going to return the result of this, so we should probably also do an integer result, or I might actually call this actual value, because this is the value we will actually get from our object to test. And the reason why I call this actual is because we can also make one called expected value. So we expect that if we add 20 and 10, it's going to be 30. So the final thing, assert, is that we should assert if these two, the actual value and expected value, are equal. And that leads me to talking about assertions, because we included this assertion, and it actually included the Jupyter one. So I could basically take this one away here. You can see we have assertions from the API as well, and that can, if we go in here, we can see we have many methods, many functions that will allow us to do some sort of assertion. And an assertion is basically about checking if two values are equal to each other. We can see assert equal, int expected, int actual. So this is just what we need, but we have versions for many different data types. And we also have other assert functions. We can see assert array equals. We have assert false, some condition if that is false. Assert does not throw, and not equals. Many functions here. And just in the end here we can see also assert null, not same. If something throws an exception or throws some expected type, many different assertions here. But we will take the, just write assert equals. So then we need to provide the expected value here. So I will write expected value and the actual value. And of course we could just write the numbers here, but I think it's pretty clean just to have the variables here. And then we can see we are asserting if our expected value 30 is equal to our actual value that the calculator produces. Okay, so now we can see that when we chose Control-Shift-10, it's going to put the configuration up here, and we can just run it again to see the result of our test. Okay, and nothing really changed here because it also passed just before. But if we modify this one bit, let's make a change in our calculator, because we can see this makes sense here. 20 plus 10 should be 30. So if we imagine that I made a mistake in our add method here, I just made a typo, or maybe I just did this here, number 1 plus number 1. If I made a typo, forgot to change this to number 2, and then we can rerun our test. Then we can see that our add method, test method, will fail because it expected 30, because we expected 30 down here, because it makes sense here, but it actually got 40. If I get this result here, that would probably, hopefully, lead me into looking into the test and saying, okay, it actually got 40. But I provided 20 and 10. I expected 30, so the test is constructed the right way. That should lead me into the add method, and then I could see what is wrong in the add method here. I know we only have one line of code, but still, I could see here, okay, I made a typo here. And then I can run my test again. And that is the really cool thing about unit test, is that I have written my test now. It could be more or less complex. Now the test will pass again here. But I can rerun the test basically the rest of my development cycle. I can reuse this test all the way through the end of the development. And that is really powerful. If I modify something in my calculator somewhere else, I can run my unit test again. I can make a regression test to see whether the change I made in the code impacted my add method. Okay, I think this is enough for the first video here about the unit test. So we introduced the AAA pattern and also made a basic unit test with JUnit. We imported the Maven dependency, and we made a pretty simple unit test, but also reusable and powerful. Okay, so hope you make this work and have fun with this. Bye bye.